Okay, good afternoon, everyone. Last class we discussed about closed loop control system, and we just finished our last lecture with the generalized block diagram of a feedback control system or closed loop control system, so to say. As you can see on the screen, we have this generalized block diagram showing on the left hand side of this generalized block diagram representation the reference input, and on the extreme right hand side you see is desired output or controlled output variable. Okay, and then from the left hand side, if we start our block diagram, we have a summing point or error detector, which does the work of comparison. So that's why it is called as a comparison element. What it compares? It compares the set value with the feedback value or the measured value. Then whatever is the deficit, whatever is the error, that error is suitably modified, manipulated, amplified, and then it is given to your control unit and then correction unit. Then in the correction unit, you might have actuating elements, and then uh, the actuating elements, like if it is a heating system, it will be electrical heater or a steam heater or a furnace. Now, if it is a robotic arm driven by a DC motor, then the actuating element or the correction element would be the motor, which will be rotating further, and the gripper will actually change the position of the gripper, or if the arm position is controlled by a DC motor, then that arm position is altered as per our requirement of the process of the system. Accordingly, the process modifications are done, and then the control variable is on the right hand side. That is our desired output. Now, whether I have achieved my desired output or not is verified by my measuring device or a feedback element, and then that feedback element will measure that parameter which is to be controlled, and then it is sent back to my comparison unit where the comparison takes place, and this cycle continues till the error becomes zero. So this is how the closed loop control system or a feedback control system works. Let us see one by one what are each unit. What is this comparison element? The comparison element compares the required or reference value of the variable condition being controlled, variable condition being controlled, and with the measured value, and that is being achieved, and produces an error signal. In simple words, whatever is my set value, the comparison element reads that set value, it reads the feedback value, it compares both the values. If there is a negative feedback, it is subtracted, and then whatever is remaining is the error signal. So error signal is equal to set value minus feedback value. So this sort of comparison it does. A feedback loop is a means whereby a signal related to the actual condition is fed back to modify the input signal to a process. Taking the same familiar case of a furnace whose temperature is to be maintained at, let us say, 1500 degrees Celsius. I have maybe a thermocouple or a thermistor or an RTD, resistance temperature detector, platinum type resistance temperature detector I have used as a feedback element. That will sense the signal. The feedback loop generates appropriate signal from the system, which can be compared with the set value. Okay, the feedback is said to be negative feedback when the signal which is fed back subtracts from the input value. Now this is very important. What is the negative feedback and what is a positive feedback? At the summing point, as you can see here, either I can have positive sign here, plus sign, or I can have negative sign here. So there is plus here, and this is plus or minus here. If there is a negative sign, that means what happens? The feedback value is subtracted from the set value. That is the meaning of negative feedback. It is shown by a negative sign in this quadrant. Okay, and if positive sign is there inside this quadrant, I'll call it as a positive feedback. Both the types of feedbacks are used depending on my requirement and need. Okay, the feedback is said to be negative feedback when the signal which is fed back subtracts from the input value, And positive feedback occurs when the signal fed back adds to the input signal. If it adds to the input signal, it is called as positive feedback. If it subtracts from the input signal, it is called as negative feedback. So this is what is called as a comparison element. See, this is the first comparison element. Then we'll see control element. Let us go to the next element. This is the control element. This decides what action to take when it receives an error signal. Now, in the initial units, we studied the transducers, we studied the manipulating devices or signal conditioning devices. Okay, so this control element is sort of a signal conditioning device also. Now, this decides what action to take when it receives an error signal. It may be, for example, a signal to operate a switch or open a valve. Okay. If it is a flow control system, I need to open a valve. If it is a steam flow control system, I need to open a valve. Okay, so it has to do, it may be for a signal, it may be a signal to operate a switch or open a valve. It may be a simple operation of a switch, which is operated by a relay. Maybe lighting a lamp, closing a lamp. So that is also one of the control actions that is expected. Control plans may be hardwired systems in which the control plan is permanently fixed by the way of elements that are connected together, or these may be even programmable systems. So the control action can be instantaneous based on my present requirement. The control action that I want is I want to have the heater output which is proportional to the error. So I need to have some proportional controller, okay, in the control element so that the error is amplified, and if the error is positive, in proportion of that positive error, my controller should generate a proportionate output control signal. Okay, or if my operation is maybe a repetitive sequential operation, right? In that case, whatever will be the changes in the system parameters, those I study beforehand, and then I prepare a program. So my programmable logic controller, or maybe my microcontroller, or maybe my microprocessor, it would work in a pre-programmed manner. If the error is so and so, take this control action. If the error is so and so, take this control action. If the error is, say, C, take this control action. I decide the control logic. So, and accordingly, I program the controller. So, and it will be in the auto mode, auto execution mode. Once that programmable logic controller or programmable controller receives the error signal, it just scans through the error signal, and in the set program, it will compare corresponding to this error value, what is the anticipated, what is the expected control action, and accordingly, it will generate the control signal. So it can be either unprogrammed or it can be programmable system where the control plan is stored within a memory unit and may be altered by reprogramming it. So this control element is very important element in this control system layout. Now the next element is actuating signal. So comparison, error signal is generated, then the control unit, and then the correction unit, or maybe the actuating unit. So the correction element produces a change in the process to correct or change the controlled condition. Now what does it mean? Take the case of a, maybe the same familiar example we'll take, furnace temperature, heat treatment furnace temperature controller. What is the objective of this control system? To maintain the furnace temperature, heat treatment furnace temperature to, let us say, 1500 degrees Celsius is the objective. And that furnace is heated by electrical coil, resistance type electrical coil, maybe of 5 watt or 10 watt, 10 kilowatt, 5 kilowatt or 10 kilowatt, which can generate temperature up to, let us say, 4000 degrees Celsius, just as an example. So that actuating element in this furnace control system is my electrical heating coil. Now, I want to maintain temperature inside the furnace. I have set it the control value to be 1500 degrees Celsius. And I'm using a transducer, a temperature sensing transducer, maybe RTD, platinum type RTD. What it will do? It will sense, it will be subjected to a temperature of whatever is the temperature inside the furnace, and accordingly, if you remember, the resistance of that platinum wire changes. And in my external circuit, which may be a Wheatstone bridge, the external circuit output voltage will vary. Let us say, corresponding to 15 degrees Celsius, the voltage that I am obtaining out of that balancing circuit of resistance temperature detector is maybe 1.5 volt or maybe 10 volt, 15 volts. Now, what is the logic I'm using? 1 volt corresponds to 100 degrees Celsius. This is the calibration constant I have, right? So, corresponding to 1000 degrees Celsius, it will generate or it will give the value of 10 volt. Corresponding to 1100 degrees Celsius, it will generate a voltage of 11 volt. So at 1500 degrees Celsius, it will generate a voltage, or it will give me the voltage of 15 volt. Now this will be sensed by my sensor transducer, which is in this case is variable resistance type RTD. It will send the signal as a feedback signal to the comparison element. The comparison element compares the actual temperature value with the set value. Now, what is the set value? Let us say I have set the value to let us say 1600 degrees Celsius is what the temperature I want inside the furnace. So 1600 degrees Celsius, now reference input elements will convert that 1600 degrees Celsius into maybe equivalent is 16 volts. I have once again one potentiometer which has got a dial, and I set the value, same calibration constant I'll be using. So 100 corresponding to 100 degrees Celsius, I'll be setting a voltage of 10 volt. Okay, for 100 degrees Celsius, it will be 1 volt. For 1000 degrees Celsius, it will be 10 volt. So for 1600 degrees Celsius, it will be 16 volt is the set value of my temperature. Now 16 volt corresponds to 1600 degrees Celsius inside the furnace. Now this set value, is 16 volt, and what is the actual value is 1500 degrees Celsius is the present value of the temperature. So 15 volt, it will be feedback signal will be generated, and that will be compared with my set value of 16 volt. So the error is set value minus feedback value, 16 minus 15, it is 1 volt. So that 1 volt signal will be suitably amplified. So it is plus 1 volt. So I want increase in the temperature. If it is minus, then I want decrease in the temperature. So it is plus 1 volt. So I want to increase. So a controller will take appropriate action, and suitably the input to the heating coil will be proportionately increased, right? And as the input to the heating coil, which is the correction unit, is increased, the process or the furnace, inside the furnace, I'll be generating more heat, and the temperature will start rising. And that rising temperature will be once again constantly sensed by my sensor transducer. It will be fed back constantly. So slowly it will become 1510, 1520, 1530. Accordingly, 15.1, 15.2, 15.3, the voltage will start rising, and then here it will be constantly compared with 16 volt. So the error is reducing. Accordingly, the corrective action will be taken up by the heating element. So this is what is the role of my correction element. Thus, it might be a switch which switches on a heater and so increases the temperature of the process, or a valve which is carrying maybe some flue gases or maybe steam. The valve is proportionately opened and allows more fluid or liquid to enter the process. Depending on the parameter to be controlled, the corrective action will be taken by the actuator. The term actuator is used for the element of a correction unit. So it is also called as actuating signal that provides the power to carry out the control action. So this is the correction element. And then we have the process to be controlled or the system to be controlled. Just coming to the block diagram. So we have seen comparison element, control elements, correction element, then the process or the system proper, whose parameters are to be controlled. So I have process, I also call it as plant element, and we'll be studying the feedback element and measurement element also in this slide. So I have a processor plant element. The processor plant is what is being controlled. A furnace temperature is being controlled. The pressure inside the pressure vessel is controlled. Or robotic system, robotic arm movement, or a robotic gripper movement is my, a robo is my system or process. And in that robo, I want to control the gripper force, or I want to control the gripper position, right? So the process or the plant or the system is the system or the arrangement of the elements whose parameters are to be controlled. The process or the plant is what is being controlled. It could be a room in a house with its temperature being controlled, or a tank of water with its level being controlled. The tank of water is a system. The furnace is my system. The room whose temperature is to be controlled is also a system. The boiler whose the steam pressure is to be controlled, or steam flow rate is to be controlled. So boiler is my system or process, or it is my plant, which is to whose parameters are to be controlled. So that is my process or system or plant element. And finally, I have got feedback element or measurement element. Now, the measurement element produces a signal related to the variable condition of the process that is being controlled. As we have taken the example of a furnace control system, this measurement element is a temperature sensing transducer, sensor transducer. It can be either RTD, it can be thermistor, it can be thermocouple. If it is the pressure that is the parameter that is to be controlled, it will be a pressure sensor or pressure transducer. So the measurement element produces a signal related to the variable condition of the process that is being controlled. It might be, for example, a switch which is switched on when a particular position is reached, or a thermocouple which gives an EMF related to the temperature. So this is the sensor transducer that is used for measurement of process parameters. So that is my measurement element. So element identification, let us quickly see an example. Automatic control of water level. Just see that figure. This water level is to be controlled inside this tank. So this is the tap. The water is coming into this tank, and I have a float type of a level controller. What will happen? Because of the buoyancy force, as the level increases, this ball will be lifted up and it will close the valve. It is simple construction that is shown here. So I have a pivot. Around this pivot, this will be lifted up and this valve will be closed as the level increases. And as it reaches the desired level, the valve will be totally shut. And as the level falls down, what will happen? As the level of the water, as it is being used for some work, the level will be falling down. As the level falls down, the float will also come down. As the float comes down, the valve will be opened proportionately. And this will be opened till my desired level is obtained. So this is the automatic control of the water level, a simple example. Now in this level control system, let us try to identify what are the functional elements of a closed loop control system. Now, why this is a closed loop control system? Because in this case, my controlled variable is liquid level. Why I'm calling it as closed loop? As the liquid level falls, that will be sensed, and accordingly the corrective action would be taken. So it is a feedback given by my this ball, float ball, isn't it? That is giving me feedback, and that is helping in closing or opening of the valve, so that the controlled parameter, that is the liquid level, is constantly monitored and controlled. So this is the automatic control of a water level inside a tank. Now let us try to identify various functional elements in this liquid level control system. Now reference value, the initial setting of the valve. Okay, whatever is the initial setting of the valve, the initial setting, I'll lift the valve. Maybe I want to have this level. Okay, and I'll be setting my valve opening accordingly. So when this is my ultimate level, let us say, for example, 2 meters. At 2 meter is the water level I want to maintain constantly. So I'll take this float valve here at 2 meters. What I do at that time, I adjust the valve to be closed. Okay, at 2 meters. So once I set it, as the level falls down below 2 meters, let us say 1.9 meters, 1.8 meters, what will happen? There will be slight opening in the valve proportionate to the error. And as the error increases, what is my set value? 2 meter level is my set value. And if the level has fallen to 1.5 meters, the error is larger. So the opening of the valve will be larger. So it's the best example of a proportional control action, isn't it? Okay, so the reference value is the initial setting for level. Okay, then comparison element is the lever. The lever works as a comparison element. What it does? It compares the set value with the actual value, right? So the error signal is generated automatically, and the pivoted lever will act as the control element. So why it is acting as a control element? Because as the level or the system parameter is changing, it is taking some corrective action, isn't it? Controlling action. It is getting lifted up. It is getting lifted up depending on the buoyant force value. Okay. So pivoted lever is my control element. Then what is my correction element, actuating element? The flap, which is opening or closing the tap or the valve, is the flap. That is my actuating element with the correction element. The flap is my correction element. And then what is the process here? The liquid level or the water level in the tank is the process. Or tank level is the process. And control variable is water level. Okay. So what is my measuring device? The floating ball and lever. The floating ball and the lever are my measuring device. Though we are not actually measuring, but it is doing that feedback work. It need not necessarily be a numerical value. It should generate and then only. It can generate a signal which will help me in controlling the flow into the tank. Okay, so that is my measuring device or a feedback device. What is that feedback device? The floating ball and a lever, and that provides me, so to say, the measured level value that will be compared at the comparator level, and the error signal will be generated, or the correction signal will be generated by opening or closing of the flap. So this is how we can identify various functional elements of a physical system and frame them into reference input, control output, comparison element, control elements, correction elements, process elements, and feedback elements, right? So this is one simple exercise we can have. Through practice, we can identify various functional elements. I think we'll stop for today, friends.